Okay, so good afternoon. Again, my name is Christopher Alviar. Currently I'm handling the cloud market for ASEAN. I'm based in the Philippines, so actually it's kind of refreshing na pwede ako magsalita ng Tagalog ngayon. So it's nice to meet all of you guys virtually, but it would be great. It will be great as well if we can have this um, face to face soon. Hopefully, we will be able to do that. So, what I'll be discussing right now is in terms of the evolution of what we are seeing right now from the workload perspective, right? So, it's the next generation workloads. It is actually here. I've been talking a lot of our customers here and even in the other countries that they're more looking at how they're able to do cloud native. So the question is, are we ready to be able to support these next gen workloads? That's what we'll be concentrating right now from how do we deploy these things? How would I be able to secure it? How would I be able to assure the performance of these applications, right? So why are we looking at this? Cloud native and microservices are now becoming the standard, right? So if you're traveling right now, you would have a ticket on your app or your QR code to do your business. And when you go to these particular businesses, when you go to redeem these QR codes or scan these QR codes, it's not just a single server, it's not just a single application. All of these is looking into microservices na pagka-scan natin ng application natin or QR code mo, it will go through a certain apps like scan and go system, then go through a gate terminal system, integrated to an e-commerce and all these things. And you look into it, what's the most common application that you may be using right now? Could be Lazada, could be all these things. On a Lazada perspective, a login would be a different application. The search, it'd be a different application. Um, the recommendation tier is going to be a different one. The chat box is a different application. And all this needs to be consumed. All this needs to be interconnected. And we need to be able to go with the market, go with the speed of that particular market so that we can have feature velocity. It's not going to be a stagnant right now. When you look into the applications, how it's being deployed right now, it's never always going to be standing in a single environment. Na parang pagka-deploy ng application ko, that's it. I'll forget about it. No. The development right now is it's going to be always going to have new features. So it needs to have the capability to have feature velocity. It also needs to have resilience. Now, if an application goes down, if your network goes down, I would still have that availability, right? Do you imagine now when you wake up in the morning, most probably you check your phone and the applications that you're using are currently down. Walang banking application. Walang Facebook, walang email. But that's not what we're expecting. We're expecting when we pick up that particular phone and system, we open the application, it's always on. That's the same expectation that our customers would have. And we need to be able to scale, right? So once there will be a lot of users, our applications need to be able to scale. That would be on the network perspective. That would be on the workload perspective. We need to be able to scale our networks. We need to be able to securely scale our application environment. Okay. And these are some of the results that we get from an IT, Cisco IT results. When we move into microservices, what's the comparison between right now when you're looking to a monolithic application? Ito yung everything is a single server. When we move to a microservices, we'll be able to increase our velocity 3 times, resiliency by 20 times, and even a scalability by 20 times. This is what the value of our customers would be looking at, right? So, but the problem is these microservices are going to be so complex. How would you be able to manage an application that is spread out across different parts of the globe? Right? So the application could, some of the microservices, some of the containers could be on AWS, could be in Azure, could be on-prem. How will you maintain and operate the underlying platforms of these rapidly changing ecosystem? When AWS isn't constant, Azure is not going to be constant. They will always have new features. how would I be able to utilize those things? When you be able to operate and maintain those platforms, how will I be able to gain visibility? How will I be able to troubleshoot faster? And then we'll look at how will I enforce my security and policy to the infrastructure and to the application. Remember, it's going to be constantly changing. It's going to constantly evolve. How are we going to be secured on that environment? Okay, so these are the things that we'll be addressing. First challenge is how do we address cloud native challenges, which is to maintain and operate the underlying platforms. So we need to be able to accelerate their cloud native from the cloud. So with our platform, where we are right now when looking at Cisco, we do have a platform called Intersight. Intersight is that cloud operating platform that we would be able to see various ways to manage cloud native application, on-prem, and even public cloud services. So it gives you that curated platform so that you can deploy applications to any locations of your application. It could be on-prem or it could be on the public cloud. This gives you we'll be able to deliver your continuous innovation from the cloud environment. Okay. And Intersight Kubernetes service would be that front and center. Intersight Kubernetes service is one of the services that is running on their cloud platform, which is Intersight. So it is an add-on, but what it gives is it helps our customer adopt cloud native environments that gives you that hardened, secured, and robust environment, right? So when a customer will be deploying Kubernetes that is going to be downloading open source environments, he has to take into consideration how would I be able to harden that? How would I be able to secure that? With IKS, we would make sure that whatever customer is going to deploy on-prem, it is always going to be secured. And all the services that it needs, right? It's not just having a Kubernetes platform. How you have to ask yourselves, now I have a container platform, I have a Kubernetes. How would I be able to access that on the outside world? So you have to figure out, I need to install networking. I need to install my load balancers. With IKS, those are automatically configured for us. Networking, storage configuration, load balancing, automatically configured for our customers so that they would just concentrate on deploying their applications on-prem securely. Okay, they would concentrate on developing their applications. And IKS has the capability as well to give add-ons to create your monitoring app. How do you monitor these containers? Remember, it's so complex right now. With IKS, we would make it simple for them. We'll be able to give them that service mesh capability. Itong service mesh, ang ginagawa nito, it gives you the visibility of your application. From a microservices environment, we would be able to know which one is going to be connected to one another. So what does it give to our customers? IKS simplifies the delivery of their Kubernetes. Remember, Kubernetes is now going to be the default standard. It's going to be the industry standard of how to deploy cloud native application. And that is how we need to be able to gear ourselves up. We make it simple for our customers to consume this by simplifying their operations from a Kubernetes deployment from day zero and even to the operations and even to the retirement of those apps. So it is cloud. Intersight is hosted on our cloud. They don't need to install anything on-prem. Intersight would be able to deliver this Kubernetes environment on their on-premise environment managed through the cloud environment. Okay. And it gives us more value. It's not just going to tie them to a single hypervisor. We do support VMware. And we also support, in the future, we're also going to be supporting bare metal Kubernetes as well as other hypervisors. This will actually reduce the risk of our customers by having a secured hardened platform for their environment, right? So how does that work? Intersight Kubernetes service. Like what I mentioned, Intersight Kubernetes is cloud managed. It is residing on our cloud. It is part of our operations platform that is secured, that is enterprise ready, that customers would be able to consume it. Intersight would then deploy the Kubernetes on-prem, so they would be able to manage and deploy everything that they need on a Kubernetes environment on the cloud, from the cloud to their on-premise environment, right? So how does that work? So if I'm looking at the Intersight Kubernetes service, we got these multiple virtualization platforms. So from a hardware perspective, that could be on a UCS, that could be on a Hyperflex, or even other environments. Your hypervisor should be vSphere, and then the Kubernetes service would be installed on top of that. So Intersight Kubernetes service, and then your containers, and then our extensions. This Kubernetes service is actually, you don't really need to install. It's on the public cloud already. And we're going to push your containers on-prem to be installed on your vSphere. Okay. And if your customers is not using vSphere, we do have our own hypervisor without the VMware if they don't want to pay the hypervisor. So our hardware would be the UCS, which is actually Hyperflex. And then you can install our own hypervisor, which is the workload engine, designed from day one to be a container virtualization. Okay, so workload engine is going to be that hypervisor to be able to support your containers. And all of these is going to be managed using Intersight that is residing on a public cloud. Okay. So just to introduce what is workload engine, it is our own operating system. Basically, it's a hypervisor. It's a Cisco hypervisor that is delivered from the cloud. So you're going to install this using your Intersight, and it's going to be pushed to your Hyperflex systems to give you that automated deployment, to give you that simplified operation. When you look, why are we doing this? Why do we have to create our own hypervisor that's going to be delivered from the cloud? Our customers are changing. They are more interested in terms of the applications itself, not anymore in the underlying infrastructure, because the applications are the ones that's going to drive business. That's the reason why our customers are open to host their apps on AWS or Azure. They don't care what their workload is or whatever their infrastructure is, as long as they're able to have these apps, as long as I would be able to deliver their applications. The same way with the hypervisors right now. As long as I would be able to deliver my application securely, with very reliable environment, and it's gonna work. Whatever below is, that's why the rise of cloud, right? We are going to make that cloud on-prem simple, giving it an end-to-end cloud native solution from and how you consume it with a security with a hardened protocol as well from a Cisco perspective. Okay. So like I mentioned, it's not just Cisco in your environment. You can actually have third-party Kubernetes. So you can actually attach and manage your third-party Kubernetes systems onto IKS. Why does that make sense? Why would I have to attach it and be managed by another Kubernetes environment? It is because of the add-ons. You need to be able to have visibility so that you can actually troubleshoot quickly. These are more in terms of when you're talking to your site reliability engineer, who would tend to focus in terms of, is it up? How would I increase my uptime? How would I be able to manage all these that they are delivered on the cloud or on-prem? And again, these applications are distributed everywhere. How do I be able to make sure that I have visibility? So what needs to happen is when our observability tools needs to be embedded into that particular platform. So it gives us the right metrics. What are the metrics that we're looking at is, what's the latency between these microservices, right? Are they secured? How would I be able to scale? How would I be able to upgrade my applications? And these are the metrics that Service Mesh Manager is going to be able to give. Gives us a graphical interface in terms of how I'm able to do it, what I can see on your environment from a microservices container. I would say, hey, I can see my HTTPS transaction. I'll be able that there is a latency across. I can see that these are traffic are encrypted, and it's not just on your on-prem. It is capable to do your Azure, your AWS, and Google Cloud. So what now? What does it bring to my table? What's the importance of that to my customer? On an observability perspective, what you can actually see right now are more of a siloed approach. AWS has their own tools, GCP has their own tools, my on-prem Kubernetes would have their own tools. What we're giving on the table, because we can actually adopt your Kubernetes approach, we can adopt third-party Kubernetes in IKS, is we're going to give them a single dashboard from all the applications that they have. And in a single view, we'll be able to know where the problem is, wherever they are residing. I'll have observability across all the entire data center, on-prem or public cloud. I'll be able to know how the latency that it is using from, hey, I'm using my database on-prem. My application, my web front end is on the public cloud. Does it have enough latency? Does it make my application slow? I would have visibility on it. If I would need to upgrade my apps, if I would need to upgrade one of the microservices, I will make it easy for them by doing a canary approach. Okay. So Cisco Service Mesh Manager is the one to be able to do these things. It gives the capability for our customers to go multi-cloud, to go multi-cluster, wherever they are, can connect any on-prem environment. And I would say any on-prem environment, whatever operating system that they're using, whatever Kubernetes flavor that they're using, and their public cloud together. Okay. It simplifies your service mesh management. Now, a single pane of glass across all these platforms and gives you in-depth metrics. Everything is policy-based app networking as well. If you're looking at policy-based approach for their networking and security, we will be able to do this as well on a service mesh. So we'll be able to help our customers do your traffic management. What does traffic management have to do with here? When you look into Facebook, right? They do some upgrades on their UI. And sometimes you get selected, hey, you can actually move to my beta application, or they automatically switch you to that app, to that front end. What basically on the back end is what's happening is I'm diverting some of my traffic towards this new version of application. But then I keep my my old one still up and running. That's actually traffic management. And we're able to automate those traffic management for you. So I have my version 1. I need to roll out my version 2. So I can slowly migrate my app, my users to version 2 while still keeping version 1 up. If there is any problem, it's easier to roll back some of the users to version 1. So it gives you that smooth application updates without any downtime, actually, because basically version 1 is still up. Also gives you complete application and health observability as well. And it gives you security on all layers between clusters and even different clouds. Okay. So this is multi-cluster, it's multi-cloud. It gives me the capability to see my microservices. We can give you a visualization of all these things. Helps you have visibility in your service level objectives, right? Do I have latency problems? Do I have rise in my peaks? It gives you that visibility. It gives you that dashboard as well from a health dashboard from all your Kubernetes nodes. Okay? So that when you move into a cloud native application, you would have the tools that are needed to be able to have visibility and to have the management simply, even simplifying those things. Okay. Another one is when you move into cloud native, another one is how to actually ensure the application. How do I ensure the security and policy from infrastructure to application? When you move to cloud native, the application deployment, it's not 6 months time, right? It is now moving as fast as possible. You're going to have rollouts from twice a week. New application features come in. There are some companies out there that are doing daily rollouts of new updates from their application. because everyone wants to go for agile. I'm not sure. Maybe you've heard about the agile development already. Why do customers like being agile? So that they would always be up to date to what the customer requires, right? So you would see services na nag-evolve. Like, I'm only offering this. The next day, may bagong services. The next day, may bago. One prime example, Grab. Grab started as a ride-hailing application, right? It was competing against Uber, where both are just using, you use Uber, you use Grab to get a car as an alternative to a taxi. Okay? That's the first use case that they do. That's their minimum viable product. Right now, you'll see Grab has a lot of services. Ano-ano yon? Grab Car, Grab Mart, Grab Pabili, everything from asking you to buy food, picking up things. They have actually evolved their services, and that's because they developed it an agile development. And when they roll out, walang downtime. They roll out new features without asking you to have a downtime or asking you, hey, may maintenance come in, then you go up. Because they're looking at agile development. They can actually change constantly, and it's going to be unique. So that's where we are looking at. And how to actually secure those apps. That's where this particular dashboard comes in. This is actually our secure application, or Panoptica, with some of the new features that are coming out. It's going to be called Panoptica. With Cisco Secure App, play this video. With Cisco Secure App, I'm able to see a dashboard of the problems or the vulnerabilities in my application. I'm seeing the events at runtime. I'm be able to see my namespaces, able to see the application environment. So if I would look at the pods or my Kubernetes nodes, I would see, hey, these apps, they have ledger DBs, are all have high risk, and I'm able to tie this to my Kubernetes cluster. Okay, and you'll be able to see that particular status. So when I click on my, then you can back into my dashboard, be able to see all these applications that are residing into those nodes. These are automatically discovered for you, and be able to see the namespaces and what protected pods are seeing. Okay. With Panoptica as well, we'll be able to have full visibility on the applications. You would be able to say, for example, I click on the Ledger DB. If I click on the Ledger DB, I'll be able to see these particular vulnerabilities. Ano to mga vulnerabilities na to? When you look into those things, immediately, these are all on runtime. That means I don't have, it's automatically discovered for me. I don't have any agents. It's a sidecar application. Secure application would be able to give me the vulnerabilities of the problems that I'm experiencing. If I would have security threats, what type of threats that I'm seeing? Right now, I'm seeing this particular account, application accounts DB that has these vulnerabilities that is high risk because the workload can run as root. Okay. When the application can run as root, that's going to be a big problem. And that means it also can escalate its privileges. So if I be able to escalate my privileges now, coming from a user going to a root capability, that's going to be a big problem to your environment. And you'll be able to see where it is residing, what type of the images, the templates that it's using. When I click on this environment, I'll be able to see at runtime, ano yung mga bugs nun. I'm seeing the bugs of my environment from this particular image and see, hey, I've got these CVE alerts already. Automatically, it's be able to discover, secure applications going to be able to discover there are problems in terms of this version that I'm using. Okay, so I'm saying this, hey, these are my alerts. You have to fix these things. And it say, hey, there is a fix available. And I click on this, I'll be able to rediscover what are those fixes for my environment. Okay. So that's basically what we are doing on a security perspective. from a runtime perspective. Okay, so automatically it will be able to discover at runtime all these vulnerabilities for your environment, for your Kubernetes environment. Be able to check what if there are any vulnerabilities. That's what we're seeing. Okay, okay? And so that's oops. Okay, but so that's how we're able to secure it. Be able to secure your agile development at runtime. Be able to build your infrastructure on a cloud native, and that includes your networking. We have the capability to connect your on-prem and even to your public cloud with our cloud ACI and ACI anywhere. So that's going to be automated. But this gets complicated, right? So remember, all your microservices is going to be exploding. The connectivity would actually going to be exploding as well. Applications continuously change. Then your new services will always get onboarded. And my data center or cloud is not just doing a single brand. It's not just Cisco in my environment. I may have IBM. I may have HP. I may have Lenovo or whatever applications that they're using. I would have AWS. I would have Red Hat. How do I able to connect all these things? How would I be able to deliver all these things as fast as possible in a heterogeneous environment? Now we're seeing that there is a rise of infrastructure as a code. What we're looking at is to codify everything. When you can codify everything, you get to codify your network. I'm able to deploy my network on a code level. I'm able to deploy my storage in a code, compute on a code, virtual machine as a code, containers as a code. Because when we deliver infrastructure as a code, it's going to be repeatable. It's going to be consistent across any infrastructure. So when a user executes a particular infra or particular code, it's going to be uniform. It's going to be the same infrastructure that is going to be using, right? When you correlate that to what's happening right now, when you go through a mouse clicks, we call that click ops. Bakit click ops? Kasi you click for you to be able to create a new network. You create on a tenant, add network, click on add network, put in your name of the network. That's why you do a lot of mouse clicks. And those click ops tends to have some problems. There may be there could be sometime na hindi lumalabas tong apps, or they may be looking at a new version. For example, there's a new version coming out. That operational manual that you're using is different. It's not using the same GUI anymore, your UI. With Infra as a code, you won't encounter those problems. So you just run this particular code, automatically be able to deploy these things. So, but let's have a definition first. What is Infra as a code? On a business definition, it allows your business to automate their provisioning methods. To be able to you automatically provision your environment in order to scale a cloud. It is actually born on the cloud. When you have customers that are using AWS, Azure, and all these things, most probably they're going to use Infra as a code. They're not going to the AWS console or a dashboard to generate EC2 workloads or to create new networks. They're going to consume that as an Infra as a code. Okay. When you look at technical definition, it is a process of managing and provisioning computer data centers by means of files. Okay. It's a code. Okay. What makes this better is it makes it faster. So you get these multiple IAC tools, Infra as a code. So Terraform is actually becoming the standard for provisioning these environments. So you also have Ansible, you have Puppet, you have Stack, you have Chef to all these environments. So those are some of the your customers might be using. Okay. On Intersight, again, Intersight is a platform. We have a partnership with Terraforms that is going to give you that integration from a Terraform cloud perspective, that you can run your infra as a code that they're using on AWS, on Azure, or Google, and be able to have the same scenario on-prem. and using the same connectivity that they're using already from an Intersight perspective. It will actually help you customers reduce the operational complexity, lower the risk and attack surface, because now they just need to secure that connectivity from on-prem to Intersight, because we'll be the one to handle Intersight Terraforms and be able to accelerate your application consistency. So how does this work? Um, your your servers or environment are all are on-prem. You've got your firewall protecting you. We got these cloud agents that would be deployed in terms of Intersight Assist that will help um, you connect to your environment. So these cloud agents, these are the ones, this is a connection broker. It is just a proxy to help you reach your on-prem environment. So we'll be able to help you connect to your VMware, connect to your Kubernetes, connect to your whatever application that they're using, whatever infrastructure that they're using. Terraform Cloud can connect directly to your public cloud provider. Okay, so this gives the capability to consume the public cloud, consume their on-prem, the same as they're consuming their public cloud environment. Okay, and they got a lot of providers. Itong providers na to, ito yung nagsasabi that, hey, I can do these infra as a code through all these hardware, through all these infrastructure. So you'll see a lot of vendors here. You'll see Cisco is one. You'll see Red Hat, you see F5, you see Fortinet, everybody's here. Okay, because and that's why it's become an industry standard, because Terraform has been pervasive in terms of creating these particular providers and the principles. And us as Cisco, we do create our own providers for Terraform as well. Okay, so a lot of customers are using this already, and in a lot of countries as well. So coming to how does it work now on an infrastructure perspective? So you have your repository, infra as a code. There is what we call a repository that your network engineer or ops would be able to access. Itong repository na to, nandito nakalagay lahat ng codes nila. So if you guys have a background in programming, this is their source. This is where they put in the source code that your network or engineer can pull, can make a branch out of it and create their own. How they maybe they're trying to create a modification of that code because they're going to deploy a new application, a new network. So they create that particular branch from that GitHub repository. Then they commit these changes and push it to the repository. Automatically, Terraform Cloud detects, hey, there's a changes in the repository. Let's ask your approver, hey, do you approve of these changes? And if it says yes, just allow it or not, it will deploy this on your on-prem or even on a public cloud. So just changing that particular code will be able to deploy all these things. Be able to discover what is existing and what is, so because it plans the changes, then you can just apply these particular changes. Okay. And then you save that particular state. So it compares now to new environment. If there is any changes, because we're able to save the state of your current infrastructure, there is a new change in the infrastructure. If there is a new rollout of new application that requires additional environments, like, hey, this application here would require a new load balancer. It will look into current state. I only have 2 load balancers. I need to have another load balancer. So instead of 2, I need to add 3. It's not gonna provision 3 load balancers again, because it knows the current state of your environment that you have 2 load balancers. So it's gonna provision one more load balancer and connect that to your environment, and then apply that again. So that's the beauty of what we're able to do. So what's the end result for our customers right now? So you may be talking to your network workspace, right? So they have their own repository. You can use Cisco repository. You can have Cisco environments like ACI, right? For these environments, and then be able to deploy your network. And remember, this could be on any network. This could be using on ACI. This could be on your SD-WAN, or it could be on SDA infrastructure, or it could be a third-party network. It doesn't matter. As long as they have a provider, as long as they're working with Terraforms, you'll be able to do this. You can create your network configuration. You can interface your VPCs, your VLANs, your all these things for you. Then your security vendors, your SecOps, will also have their own workspace that they can provision your firewalls, your load balancers. They're using FTD. They can actually deploy the new virtual machine FTDs or third-party infrastructure for your load services. So all the configuration that they need can be written as a code. You can create load balancers, create firewall rules, deploy load physical hardware as well. Okay, and in a compute workspace, you can actually deploy your RUCS, our Hyperflex on these environment, your hardware. You can create your service profile. You can create your fabric policies as well. Deploy operating systems, be it our own operating system or be it on a third party like ESXi. You can deploy that remotely as well. Deploy Hyperflex and deploy all these workloads as well. So your Kubernetes can be deployed as a code. Your add-ons could be deployed as a code to give you even the application development could be deployed from a security perspective and even the customer applications. And that can all be delivered using using solutions like this to make it simple for your customers, to make it as fast as possible to your customers, to make them ready for the next generation cloud. Even experience monitoring. I've seen during the game, you've been complaining about ang bagal naman ng ISP ko, ang bagal naman ng ganun. It's actually a very good scenario where how would I be able to know that it says is it my app? Is it WebEx that's having problems? Or is it the ISP that's having problems? We'll be able to deploy agents as well to be able to make sure that those things. And one of those agents is Thousand Eyes that will make sure the connectivity from the end user to your apps is actually good or not. We'll also give them the advice. Okay. So what's the outcome? What's the business outcome for our customers? If you're talking to developers, they usually use this already. So with application developers, they can create and utilize the native 100% Kubernetes services. They're not going to use a different tool. How they're using their existing tool is still doing it the same way that they're using this. From a NetOps perspective, they can deploy Infra as a code across your DC, across your WAN, across your local area network as well. Make sure that everything is compliant. And in fact, Infra as a code on the hindsight also gives you another use case wherein I can revert to the previous code. I can revert to the previous infrastructure. I would have versioning control as well. So I can monitor these environments. SecOps be able to make sure that every policy is followed, make sure that I'll be able to have all the codes that I'm using is actually secured. All right. One, if you're able to deploy these infrastructure as fast as possible, we need to be able to make sure that they would always be running. We need to always assure that that the applications are performing well, right? So how you need to be able to make sure of that. It is beyond human scale. Remember the microservices picture? There's a lot of webs. How do we able to manage those things? This is a butterfly effect. Like for example, our customers are going to be deploying another application. The developer are going to be going to play it safe. Let's be safe. I'm going to request a lot more dedicated CPU and memory because I don't want my code to be I don't want my code na masira. I don't want my applications to go wrong to have any problems based on resources. So they commit based on this particular environment, I'm gonna request 64 gig of virtual RAM, 16 virtual CPUs. All good, they're the developers, nobody's gonna complain. But then when you look into this, how does that affect the site reliability engineer? Based on the specs that I receive, you guys, I need to deploy 2 more nodes. I need to buy more servers because we're running out of memory and you're going to request me 64 gig of RAM and I need to deploy 2 because I need to be sure that it will always work. I need to make sure that I'm designed for downtime. And your infra engineers on a public cloud perspective would say, okay, we're going to design 2 more application nodes. When I go to my infra engineers, or for example, a cloud engineer, so you need app nodes. Okay, let's provision more EC2 instances. Let's provision more resources on the cloud. No, I really don't understand it, but you ask for it. Okay, provision it. But then the CIO is going to ask, why is my cloud bill so bigger? I thought we are supposed to save on infrastructure. I thought we are supposed to save on resources on my cloud billing because of microservices. So the problem in that is most of the applications are over allocating their resources, right? They're over allocating your resources to attempt performance assurance. The problem is it's gonna be a bill shock for them. Workload Optimizer, it gives you that complete visibility from infrastructure to application. It is a resource management tool. I'm going to help our customers plan for this and make sure that they're not overspending their budget from a cloud perspective to an on-prem, because we're going to assure the performance of your application. Remember, your developers are over assigning resources just because they want to assure the performance. What if we're going to be able to help them assure the performance at day one? With Workload Optimizer, that's what we're going to assure. Assuring that all your application will have the resources when they need them, when they need it, to assure the performance of your app. It simplifies the resource management to you and reduce the OpEx and even preserve that capital, because this can actually be on-prem or could be on the cloud, a single dashboard and able to adapt to changes and reduce this risk. When you deploy an application, it's not going to be a constant demand, right? When you deploy these particular services, sometimes their demand goes up, sometimes the demand goes down. So we'll make sure that the application size, the resources that are assigned to that is going to be always equal. We're going to equate the supply with the demand of your application to make sure that they will have the performance that they need. Okay. What we do is, with Workload Optimizer, is going to abstract the workloads. We're going to abstract the application workloads and capture the dependencies. We have the capability to look into the entire supply chain, from the application to the containers to the virtual machines to whatever region or whatever account that they're using, on-prem or public cloud, and analyze them, model that, so that you would make sure that you will have the capability to see, hey, I need less resources on this. I need to size down my EC2 instance. Like my AWS bill will able to I will be able to decrease my AWS bill because I am assuring my performance. And that can be all automated to your environment, be it on-prem or be it on public cloud, whatever device that they're using, be it a non-Cisco or a Cisco device, be it on-prem or public cloud, be able to make sure those things are automated. So if you look into the market right now, I see a lot of softwares that are doing cost optimizers. Workload Optimizer is not a cost optimizer. It is a resource manager that assures the performance of your application. It's only Workload Optimizer that can assure the performance out there. We'll be able to give you automated actions to size, to place, provision your resources. So how does it look like? This is the supply chain that we're seeing. I can take out my app dynamics. I have visibility on my APMs. I have visibility on my Kubernetes. I will have visibility on your vCenter, on your storage, on my compute, even on a public cloud. I will see visibility on AWS, Azure, on a single dashboard. If those apps are in those public accounts, I'll be able to have visibility on them. And this is done for you automatically. You don't need to tie this together. Don't need to discover this. This is automatically discovered for you. And you would see where the congestions are. And we'll give you the actions that needs to be done to get these to prevent those congestions. Workload Optimizer is going to give you transform those data. It doesn't matter that I've got all this monitoring tool already. Why do I need this one? Unless you transform that visibility, those data into insights to give you that end to end. So what we'll give is we visualize your workload, get in front of the problems before they happen, and make sure that we give you the work cost optimization from there. Okay. The main value of this is to get in front of the problems before they happen. And as a summary, with all these software that we're talking about, Cisco can actually help you build that cloud-ready environment for the next gen. You can modernize your cloud management infrastructure, operate cloud smart in a way that I have visibility in my clouds, and even help my customers accelerate to cloud native. If you need more information, you can contact us or contact VST to have a one-on-one session with you guys. I'm here in the Philippines anyway, so we can have those sessions. With that, I'm passing the ball back to VSC. Any questions?